Hello, my name is Ram and welcome to another video of Matuklasan. And in this video, we'll be discussing two one-sample statistical tests. The first is the zTest for a population mean. The zTest is a statistical test for the mean of a population. For instance, you can use this if you want to test the significant difference between your sample mean and the population mean, as long as you follow these assumptions. First, the population standard deviation should be known. The sample is a random sample and the sample size should be greater than or equal to 30. If it's less than 30, you need to make sure that the population is normally distributed. And this is the formula that we need to solve for the value of z. X bar represents the sample mean. The mu represents the hypothesized population mean. Sigma is the population standard deviation. And the square root or the n here represents the sample size. Let's take a look at this example. It has been reported that the monthly average credit card debt for adults in a city is 10,000 pesos. However, a financial analyst feels that it's greater than 10,000 pesos. So he conducts a study of 50 randomly selected adults and finds that their average debt is 11,250 and the population standard deviation is 1,120. With an alpha level or level of significance of 0.05, is the analyst correct? In my previous video titled Fundamentals of Hypothesis Testing, I summarized the steps into 5 whenever we want to use the critical value method for hypothesis testing. The first step is to state the hypothesis and identify the claim if necessary. In our problem, the hypothesized population mean is 10,000 pesos. And since the financial analyst is claiming that the mean is greater than 10,000 pesos, then the alternative hypothesis is mu greater than 10,000 pesos. And the null hypothesis is just less than or equal to 10,000 pesos. But if you want, we can change this less than or equal to just equal sign. In other words, the null hypothesis states that the monthly average credit card debt for adults in a city is 10,000 pesos or less, while the alternative hypothesis tells us that the monthly average credit card debt of adults in a city is greater than 10,000 pesos. And if you're having trouble identifying the hypothesis, please watch my video titled Fundamentals of Hypothesis Testing. And now, to continue, since the alternative hypothesis is greater than, the type of test that we have is right-tailed. After which, we need to choose or identify the level of significance, sample size, and statistical test. The significance level is 0.05 as stated in the given. The sample size is 50. And since the financial analyst is trying to compare the sample mean to the population mean, the zTest is the appropriate test for this one. And since the sigma is known and the sample size is greater than 50, the assumptions for the zTest are met or were met. To identify the critical values for the zTest, we're going to need the z-distribution, also known as the normal distribution table. You can find it in Google or at the back of some statistics books. But for convenience, here's the summary of those critical values. If you have a left-tailed test, notice that all the critical values are negative and you will depend on the level of significance. If it's right-tailed, all critical values are positive. Now, if you have a two-tailed test, remember that you have two possible values, the positive and the negative value. Our example is a right-tailed test. If our significance level is 0.05, then the critical value should be positive 1.65. By using the formula I mentioned a while ago, we'll be able to use or find the test value. Z is equal to 11,250 because this is the sample mean, minus 10,000 for the population mean. The population standard deviation is 1,120, and since n is equal to 50, we'll have a value of 7.89. Finally, to make a decision, we need to compare the critical and the test values. Our test is a right-tailed test, so in the distribution, This must be the critical value. Remember that the critical value separates the critical and the non-region. As mentioned, our critical value is 1.65. Now, since this is a right-tailed test, this shaded part is the rejection region or the critical region. Our test value is 7.89 and it's a long way to the right. So 7.89 is somewhere here. And since the test value 7.89 is greater than 1.65 or in the rejection region, we need to reject the null hypothesis. But what if z is 1 and it's on the non-critical region? Well, the decision if it's less than 1.65 or it's on the non-critical region, then we don't need to reject the null hypothesis. But the answer is 7.89, so we need to reject the null hypothesis. Now, since our decision is to reject the null hypothesis, then there is enough evidence to support the claim that the monthly average credit card debt of adults in a city is greater than 10,000 pesos. So the financial analyst is quite right if we are basing our answer on the z-test. Let's try this example. According to phindeed.com, the average salary for an accountant in the Philippines is 26,425 per month. Suppose a sample of 40 triple T's accounting firm accountants showed the sample mean of 27,685. If the population standard deviation is 3,000, is the sample mean different from the population mean at 0.01? In this example, the population mean is 26,425. The sample mean is 27,685 and is equal to 40. And the population standard deviation is 3,000. Also note that we are only after the difference of the sample mean from the population mean. So it doesn't matter if it's greater than or less than, so we have a two-tailed test. For the null hypothesis, we will use equal and not equal in the alternative hypothesis. The critical value is 2.58 and negative 2.58 because it's a two-tailed test and the alpha level is 0.01. Using the formula, we'll get a test value of 2.66. It's a two-tailed, so the critical regions are on the left and the right side of the distribution. So the critical values are right here. Negative 2.58 is here and positive 2.58 is here. Since 2.66 is on the right most part of 2.58, then we need to reject the null hypothesis. If you want to use the p-value method and you are using distribution tables to find the p-value, then we can follow these steps that I discussed in my previous video. In the previous credit card problem, we start by stating the hypothesis and solving for the value of z, which we already had a while ago, right? Which is 7.89. So we just need to discuss how to get the p-value for this test. To find the p-value, the first thing that we need to do is to find a table that is a cumulative standard normal distribution. In my case, I'm using Appendix C of the eText Elementary Statistics by Blumen. To start, we need to identify the test value. And if, let's say, the test value is negative 3.41, I need to find the cell where negative 3.4 and 0.01 intersect. So if the test value is negative 3.41, then I need to get this value. If the value is, let's say, 1.2, so I'm going to use this cell or the value in this cell. If the value is 1.21, then I need to use this value in this table. After identifying the value in the table, we can use these guidelines to identify the p-value. let ZT be the value from the cumulative standard normal distribution. If it is left-tailed, the p-value is the value that you got from the table. If it is right-tailed, you need to subtract the ZT from 1. If it is two-tailed, you need to get the 1 minus ZT and multiply it to 2. You need to note that this is only applicable if the area is given in the left side of Z, or you are using the same cumulative distribution table that I'm using. In our example, the Z or the test value is 7.89, but notice that we don't have 7.89 in this table. So for Z values greater than 3.49, we need to use 0.9999. By subtracting 0.9999 from 1, we will get the p-value of 0.001. And we always use this for Z values greater than 3.49, and it's a right tail like this. Example, since the p-value is less than the alpha level, which is 0.05, then we need to reject the null hypothesis. And this verifies our answer in the critical value method. Make sure to check my other video entitled The Fundamentals of Hypothesis Testing to know more about the decision when it comes to using p-values. Let us use the other example about the average salary of accountant in the Philippines, and this time I changed the sample mean to 26,700. If the population standard deviation is 3,000, is the sample mean different from the population at 0.01? So this time we're going to use the p-value method. For this example, we have the same hypothesis. It's a two-tailed test, but we changed the sample mean to 26,700, so the test value now is 0.58. So the test value is 0.58, so it's 0.5 and then it's 8 here on the hundredths digit. So 0.58 and the cell that we need is 0.7190. Now, subtracting this value from 1, we'll get 0.281. But remember that this is a two-tailed test, so we need to multiply it to 2 so that we will have a p-value of 0.562. Since 0.562 is greater than the alpha level, then do not reject the null hypothesis. If you notice, I divided the alpha level 0.01 into 2 because this is a two-tailed test. Using distribution tables to find the p-value has its limitation. That is why we can use computers and calculators to find the p-value easily. Please watch my other videos explaining how to use the p-value in SPSS and Microsoft Excel. Aside from zTest, tTest for a population mean is one of our options when the population standard deviation is unknown and we want to test the mean of a populations. So we need these assumptions for this tTest. The population standard deviation is unknown, the sample is a random sample, either n is greater than or equal to 30, or the population is normally distributed if n is less than 30. The formula for the t-test is almost the same as the z-test. T is equal to x bar for the sample mean, mu for the hypothesized population mean. We change now the population standard deviation into sample standard deviation, and n is still for the sample size. For example, the average local cell phone call length was reported to be 2.27 minutes. A random sample of 20 phone calls showed an average of 2.98 minutes in length with a standard deviation of 0.98 minutes. At alpha level 0.05, can it be concluded that the average differs from the population average? So here, 2.27 minutes is the population mean. 20 is the sample size. 2.98 minutes is the sample mean. So this is x bar. 0.98 is the sample standard deviation, and the level of significance is 0.05. Let's try using the critical value method first. And for the first step, we need to state the hypothesis and identify the claim if there is. Now, since the hypothesis mean population is 2.27 minutes, our null and alternative hypothesis are this. The alternative hypothesis is not equal because we are trying to verify if the average differs from the population mean. We don't have a claim for this problem, so that our null hypothesis is the average local cell phone call length is 2.27 minutes, and the alternative hypothesis is different from 2.27 minutes. To identify the critical values, we're going to need the level of significance, the sample size, and the degrees of freedom. The degrees of freedom is n minus 1. N represents the sample size. Since the sample size in the problem is 20, then 20 minus 1 is 19. The type of test that we have is a two-tailed test. The t-distribution, which we will use later to identify the critical values, is a family of curves. That is why we need degrees of freedom to get the critical values. The t-distribution table that I'm using looks like this. Other tables only have one tail, so if that's the case, you need to divide it, or you need to divide the alpha level by 2 to get the two tails. In our example, the degrees of freedom is 19, and it's a two-tailed test, so I'm going to refer to this column. Since the alpha level is 0.05, then what is our critical value? So the critical value that we're going to use is the cell containing the value of 2.093. Because this is the intersection of degrees of freedom 19 and alpha level 0.05 using the two-tails column. For the critical values, if it's a right-tailed test, it's always positive. If it's a left-tailed test, you need to insert a negative sign in front of the value from the table. If it's a two-tailed test like our example, we need to indicate the two critical values. Because in the illustration, it will probably look like this. This is for the 2.093 value, and this is for the negative 2.093 value. And these are your critical regions. The next step is to compute for the test value. The sample mean is 2.98. The population mean is 2.27. The sample standard deviation is 0.98, and the sample size is 20, so that the t is 3.24. And since 3.24, the test value is greater than 2.093, or the critical value, then we need to reject the null hypothesis. Because it's negative or positive, rather, I use the right side of the critical value, which is 2.093. It's on the critical region, so therefore, we need to reject the null hypothesis. But if ever it's less than 2.093, say t equals 1.02, then we need to retain the null hypothesis. But if it's, let's say, negative 3.24, then you can still reject the null hypothesis. But this time, the value of t is negative because it tells us that it's less than the mean or the population mean. Now, how about this example? According to NDHS, Filipino households consist of an average of 4.2 people. However, a barangay captain thinks it is lesser. So his staff randomly selected a sample of households in their community and resulted in the following family size. At alpha level 0.01, is there enough evidence to support the barangay captain's claim? The population mean here is 4.2. And the sample size by counting the data is 22. The alpha level is 0.01. But we don't have value for x bar and the sample standard deviation. So for this, we need to compute the sample mean and standard deviation using this data set. And we'll get 4.05 for the sample mean and a sample standard deviation of 1.25. This time, we have a left-tailed test, and the alternative hypothesis is the claim of the barangay captain because he said that it's less than or might be less than 4.2. And of course, if this is less than, we have a left-tailed test. The alpha level is 0.01. The degrees of freedom is 21 because the formula is n minus 1. N is 22, subtracting 1 will give us 21. And we have a sample t-test as our statistical test. Using the t-distribution table, I'm going to look at this column because we have a one-tailed test and the alpha level is 0.01, so I'm going to use this column. And now, by looking at 21, which is our degrees of freedom, the critical value is 2.518 according to the table. But we have a left-tailed test, so it should be negative 2.518. By using the t formula or test value, or the formula for the t-test, we'll get negative 0.56. Ano ba yan? Now, we have a left-tailed test, so the distribution should look like this. And we have a left-tailed. The critical region is here. The critical value is negative 2.518. And negative 0.56 is somewhere on the right side of negative 2.518. And this time, it's greater than the critical value. Since the t, which is negative 0.56, is not on the critical region or it's in the non-critical region, therefore, we need to retain the null hypothesis. So our decision is do not reject the null hypothesis. So we will not reject this and we will cross this out. Therefore, we don't have enough evidence to support the claim of the barangay captain because there is no significant difference in the population mean. Aside from the traditional critical value method, we can also use the p-value method. In this example, a physician claims that jogger's maximal volume oxygen uptake is greater than the average of all adults. Now, he has a sample of 15 joggers and has a mean of 40.6 millimeters per kilogram and a standard deviation of 6. If the average of all adults is 36.7, is there enough evidence to support the physician's claim at alpha level 0.05? So now, the sample size is n, the sample mean is 40.6, 36.7 is the population mean, while 6 here is the sample standard deviation. Also, this is a right-tailed test because the physician claims that the average of all adults is greater than. The null hypothesis for the problem is mu equals 36.37 and mu is greater than 36.7, and this is the claim of the physician or of the doctor. And by using the formula, we'll get a t-value of 2.517. To find the p-value, we'll be again needing the degrees of freedom. Since the sample size is 15, subtracting 1 from 15 will give us 14. So if you are now using the distribution table, the first thing that we need to identify here is the type of test. Since we have a one-tailed test, I'm going to look for this data or level of significance column. And we have a degrees of freedom of 14. Now, all I have to do is to identify the test value. The test value in our example is 2.517, and looking at this row, 2.517 is between 2.145 and 2.624. By looking at the column or columns that correspond to these values, we have 0.25 and 0.01. So, going back in our solution, the p-value is between 0.01 and 0.025. Yes, we only have an interval here and we won't be able to identify the exact value for the p if we are only using the t-distribution table. If you want to get the exact value of P, we can use computer softwares like Excel and SPSS, or a scientific calculator that has that kind of function. Or you can just watch my videos, right? Given the range, the p-value is less than 0.05, or our level of significance. Therefore, we need to reject the null hypothesis. And rejecting the null means we need to support the claim of the physician that the population mean is greater than 36.7. To avoid any confusion whenever you want to decide how to use Z or T test, you can follow this guideline. So the first thing that you need to ask is if the sigma is known or the population standard deviation is known. If the population standard deviation is known, then you can use the Z test. If the population standard deviation is missing, you can use the T test. But remember that N is greater than 30, or if it's N is less than 30, then the variable must be normally distributed, or the type of variable that you are using is assumed to be normally distributed. And that's all for this video. Please watch my other videos showing how to use Microsoft Excel to find the critical and p-values for one sample test. And please like, share, and subscribe to keep yourself updated. Thank you for listening.